what we're seeing a little bit. It's like the entry point. So like 10, 12 years ago, people were like, yeah, I want to be more agile for various reasons. Now it's like we're finding ourselves in a world where if we're not taking costs out, we're not making things more secure, we're not improving efficiency, flow, all those different things in a very measurable way. People have less appetite for change's sake, or a hypothesis that Agile is going to solve it. So again, what I think super interesting is that security is a big deal, right? Cloud costs are a big deal. Getting ready for AI is a big deal. And you have to work backwards. So you say, okay, that's a big deal. What conditions do I need to create in my code base? What conditions do I need to create in my organization so that I can exploit these things and these capabilities in the future in a more scalable way? Hey everybody, Mike Hotmeyer from Leading Agile. Thanks for joining us today on this video. We are going to explore something that is a little bit different than the topics that we typically explore, but it's really adjacent to a lot of the things that we're doing in the Agile transformation space. And so I want to introduce everybody to the CEO and founder of a company called Rampart AI. And so Lee Krause. Lee, tell us a little bit about yourself and what you do. What does Rampart AI do?
Sure. Thanks for having me, Mike.
Yep.
So for myself, I'm a computer engineer by degree. I've been in the field for about 30 years. We've been part of the National Cyber Defense Team and really have focused on cyber over the last 7 years, going after what we consider to be emerging threats, high-profile threats. And so we tackled a problem a little bit different than most. We were actually looking at how do we understand good behavior of your applications, and if we understand good behavior, we can detect threats. So, and security is everywhere. I think you're seeing it in the SEC requiring fiduciary duties associated with cyber. I think it's in the news constantly. So I think everybody should care about cyber, and I think we can dive into that a little bit today.
Yeah, for sure. So what was interesting about mine and Lee's relationship is that he and I have a shared business advisor, a gentleman named Doug Tatum, who introduced us. And so it was one of those exploratory conversations where I was asking Lee what he does and he was asking me what I do. And more often than not, when we're in the Agile transformation space, we're getting into issues of app modernization, product extraction. A lot of the things we're doing have to do with cloud optimization now, because at the end of the day, if we can't, we talk about encapsulation versus orchestration around here all the time. If we can't get monoliths broken up, we can't get engineering modernized and such, then it's really tough to play in this space of business agility. So what I thought was interesting about Lee's product when he started talking with me about it is that he takes a really interesting approach to security, and there's some aspects of cloud and app modernization and engineering modernization that became pretty relevant. So Lee, tell me a little bit, let's talk a little bit more deeply about what Rampart AI does and how it approaches, I guess, the security apparatus. I think it's a fairly unique hypothesis that you have. Could you go into that a little bit for us?
Sure. So back to the earlier statement, security is everywhere, whether it's a legacy app or a new app that you're building. And it's a changing environment. It's hard to keep up. So what Rampart really focused on is how do we understand what normal behavior is for an application or a container, part of that encapsulation that you talk about. And if we can understand how the application's supposed to behave, we're able to then detect when abnormal things occur. And abnormal things can anything to truly be a cyber threat, poorly tested code, just things that we haven't seen before. And I think that brings a lot of insight into the whole modernization process. It allows you to do an encapsulation of a product and ensure that as you're modernizing it, you still have security boundaries associated with it. And as you continue in that modernization, you're able to monitor the security of that application during runtime, which I think is one of the most critical things moving forward. That we're going to start to see that move away from what we viewed as the moat, which was everything was protected by a firewall or a WAF, based on brittle rules and moving into forcing people to understand how their applications work, where the supply chain, where they came from, things of that nature. And I think once you start to think about that problem a little bit, you really start to see how our products really play together. When anytime you're doing modernization, you want to ensure that you're taking the applications that you have and putting them in a better security posture when you're completed the modernization. I think Rampart allows that journey to occur very effectively.
Yeah. So when you were first explaining it to me, talk about the conditions that are required for Rampart to work well. And kind of what I'm hunting for a little bit is, I think when you and I first started talking, you guys will generally take an approach. Like, let's say you walked into an environment where maybe apps weren't modern, maybe apps weren't, like, how does your product secure the boundaries, secure the perimeter of a software solution?
So mainly what we're trying to do is go with a more modern approach to software, which is using containers, whether they be Kubernetes or Docker containers, so that you have a way to gain the flexibility of running that application on many cloud environments, hybrid cloud environments. It's just that containerization of it. And you use the word encapsulation. Well, the container is providing that encapsulation that allows it to be more mobile, and mobile is moving around from server to server and things of that nature. And I think so encapsulation, what it allows us to do is set boundaries for us to understand the system calls that are associated with that container and using them to determine what is the normal behavior of that container. What files does it read and write from? What ports does it access? Things of that nature that are unique to that container. In addition to that, what we do is we allow you to provide operational tests. We use those operational tests to basically build the behavior model. And so ideally you have a significant amount of operational tests, in which case we build a very complete behavior model. If you have no operational tests, you have a way to basically start and gain a 90% understanding of how the app ultimately works from startup, and then continue to refine it over time. So that's from the standpoint of looking at it from a container standpoint, that encapsulation. In addition to that, we can look at the language of that application as well and do instrumentation of that to get a finer granularity, ensuring the app behaves as expected. So I think there's a lot of things to do that we can do, tools in our toolbox, based on what your application's doing and your risk profile.
So that was one of the first things that you said to me that kind of piqued my attention. So does Rampart AI, does it basically take the existing automated test framework? Does it take the manual tests? Like, how do you train your AI to protect an application and to make sure that it's secure?
So we look at it from a standpoint as organizations go through deployment cycles to become part of the CI/CD pipeline that allows your organization to rapidly deploy applications. What Rampart does is become part of that pipeline. And so it actually just naturally builds the behavior model as part of deployment. So majority of organizations will never even know Rampart's running, except when it detects abnormal behavior. It's just built into the CI/CD pipeline.
So let's talk a little bit about how security is typically handled outside of your world. My understanding, I grew up in infrastructure and security, and so I have a little bit of background, enough to be dangerous, around like penetration testing and remediation and security policies and such. My understanding of the existing security landscape is that we have policies, we write software to be compliant with those policies. And then through that build process, we test through penetration testing and other tests to make sure that the app is secure. Let me ask this question. So is that valid? Do you have it? Like, why don't you tell me a little bit about how you understand the current state of the security landscape?
So I think security has many layers. So you've described the outer layer of, you have firewalls that have rules that determine who's whitelisted and blacklisted and allowed on your network. You determine policies associated with which ports are opened and closed, right? At that next level of detail is the application itself running. And so how do you ensure that the application itself is running as expected, which is important, that there's not a supply chain attack. People aren't already inside of your network.
Yeah, talk to me
Right.
about that. You've said supply chain attack a couple times. What is a supply chain attack in your world?
So supply chain attack is when a organization gets into your pipeline associated with how you develop code. So for SolarWinds, they broke into an account and ultimately modified code that ultimately got deployed. For the XZ application, which was recent vulnerability that was detected, it was a group organizing basically open source code, submitting changes over a 2-year period. So it's actually applying softwares that you're using to develop your software application. There's many layers, and it's that supply chain of what are all the layers that are associated with the application that you're building. Because in general, people are focused on writing code that allows their application to work, but they don't realize all of the libraries and other components that they're using that other people have built that they're just using with this blind trust that it's going to work as expected. And whether
okay, so see if I understand. So the current security model is we're basically protecting from access to the system. So we're securing the firewalls, we're locking down ports, and we're trying to protect the perimeter. What you're saying with the supply chain thing is that the code and the modules that we're using as the fundamental building blocks of the application have somehow been compromised.
Correct.
Yeah.
Correct. And I will just add another thing. What currently we do is we have this whole hypothesis that all of our known vulnerabilities, we continue to search and pen test for known vulnerabilities. But your greatest threat is the unknown, right? Because you can patch and you can ensure that your code does not have vulnerabilities or try. It's a little bit of an endless fight just because of emerging threats associated with generative AI. But in general, the mindset was that we could keep up with the cadence of known vulnerabilities to patch our systems. And I think what we're seeing now is we can't really do that. And the tools that we have in place are very static based. And the modern, or I'd say the future of cyber, is much more at a rapid pace that's occurring based on generative AI, based on supply chain threats, things of that nature, which all are occurring at the application layer, which is really going to be the next frontier. So you see today where we talk a lot about ransomware gangs, and ransomware as a service. I think the future term is going to be exploits as a service. These criminal gangs are going to get exploits that were built off of generative AI or backdoors that were built into your supply chain. And that's how they're going to access your system and gain a new foothold to extort or steal ideas, money, and things of that nature. So you're going to see that rapid evolution. And so one of the things that really changed is that in the last 5 years, you had to be a large nation state to do a sophisticated attack. What you're seeing now are, I'll call it thugs, teenagers that are actually able to implement attacks because it's sold as a service. So the whole thing's changing because of AI. The skill set that you need is not at a nation state level, but it's available to just about anyone.
So, okay, so I'm gonna have to back this up a little bit and see if we can start piecing this together for everybody. The metaphor that I tried to use with you as I was testing for my understanding of what you guys are building, it was a little bit like, I say back in the day, I guess it's still a thing, the idea of like virus scanning and virus protection. And so the idea is that we know the signature of the virus. We scan for those different signatures. When we identify the signature, we remove the virus. And I was thinking about that from the perspective like an analog with security vulnerabilities. Like we understand the security, we patch for the security, we test for the security, But what you're saying is that because of the supply chain of software, quite often the security vulnerabilities are getting built into the software as the software is getting constructed, and might sit dormant in the system behind the firewall for a long time, and you never know it exists. And so you guys have created some kind of dynamic way that enables detection of a difference of behavior or something that allows us to understand if we're being exploited without even knowing the signature of the attack?
Correct.
Okay.
So I think that's a really important discriminator from our product from just about every other product that's out there. The mindset today has currently been signature heuristic based, that you did a search for that application, whether you did it during development, whether you did it at deployment, to try to ensure that no known vulnerabilities were actually being deployed and that everything was patched as expected. A daunting task in itself. Just a daunting.
We have tons of clients that probably spend 80% of their development time remediating and chasing security defects from pen tests.
Right.
It's
and
impressive.
It's just,
yeah.
I kind of look at it as it's a losing battle. You're never going to win the cyber war trying to catch up through patches. So when we were challenged with coming up with a way that we could detect supply chain attacks, we kind of said we had to think a little bit differently. And what we decided was the only way that we could figure this out was to basically understand how the application is supposed to behave. Because if you understand how the application is supposed to behave, you ultimately have the ability to detect abnormal behavior. We like to call it going off the rails. So you're able to very quickly see the application do something that we've never seen before. We can determine based on what they're doing, is it something that should never ever happen? Is it something that's associated with poor testing? Is it something that someone just needs to look into? So I'll give a real example on that. So Log4Shell was a real thing probably about a little over a year ago. It wreaked havoc associated with IT organizations and CISOs trying to figure out what their exposure was to this bug in their code that allowed basically someone to get root access on their box by doing a simple exploit. So what Rampart did, as soon as this came out, we had Rampart up in our lab. We took and tried to implement the attack. The first time you implement that attack, Rampart immediately realizes what you're doing is something we haven't seen before and detects it as an error. When you get to the point where it's kicking off and the actual talking back to the netcat listener, it actually stops the attack itself. It just blocks it. And it's doing this because it's seeing things that it's never seen before at a level that we say should never happen.
So it seems like there's two angles that maybe you could explain to me. So it's like if there is a test suite, so let's say somebody was a great agile shop, modern engineering practices, they were doing test-driven development, continuous integration, deployment. Does Rampart, does it learn from the tests and then learn from the behavior too? Is that how it works? Or tell me more about it maybe.
So there's two sides of it. So it learns from the test, sets the foundations for what are the major paths. But in modern software, there's many different paths that can be taken. So it has to infer and use some AI to determine what is the range of acceptable behavior. And so we spent a lot of time trying to figure out. That was one of the difficult problems to overcome, because there is some internal learning to say that's just a different path, but it's doing the same thing. We know it's okay. So there's that two level of it. There's the level which says this is the use case or thread that's acceptable, and then the variations of those threads that are also acceptable.
Okay. So we were having a conversation the other day with one of our shared clients around the idea of like code paths that aren't exploited or dead code in the system. Tell me a little bit about how Rampart looks at that and what it can do to help in that area.
So I think really what you're referring to is that there are potentially vulnerabilities that are just not worth patching or too hard to patch, and they don't impact the system itself. what Rampart does is ensure that those paths can never be taken. And in doing that, it's ensuring that you don't have to patch it. We'll never allow it to happen within Rampart. And again, I think it comes down to, our philosophy is that bugs that are in your code should be patched, but we would think that you should patch them on your terms. So for organizations that run, a monthly development cycle, they can do it there. For organizations that feel that that code's never ever going to be used, and they're just happy knowing that we're going to block it, I think that's totally acceptable as well. And for that client, it was portions of the code that it was just going to be too expensive to make changes to that code. So it's a much more cost-effective way to use Rampart to basically be able to block those threads.
Okay. I'm going to take a step back in the conversation a little bit. There's probably some things that, maybe you can't share publicly. I know you guys do a lot of DoD work and things like that, but what was like the initial market opportunity or problem you solved that prompted you to go down the path of building this product?
So we were challenged. As part of the National Cyber Defense Team, there was the notion that nation states could use supply chain as a way to ultimately infiltrate software baselines. And this was even before SolarWinds. And they wanted to have a way, how could you detect at runtime that your code base is performing differently than you expected, and be able to monitor and detect this at runtime was a challenge that we were given. And once we realized that, knowing that heuristics weren't going to work, that we didn't have access to the code potentially all the time. So how are we going to be able to determine that the system's not behaving as expected? And that's really why we went down the path of using the behavior model. And it's we like to use the term flipping the coin. Instead of worrying about everything that's bad out there, let's focus on what we know is good. And if we can continue to focus on what's good, the bad will basically pop out at us. And it does. It's really amazing how effective it is.
Yeah, there was a recent attack. I'm probably going to get the name of it wrong. XD or something like that?
XE.
XE was tell us about that vulnerability and how you guys dealt with it.
So XE was an attack that was in Linux side of the house. And it was an attack over 2 years. It was in the XE library is the library that was used. And it's an encrypted library as well. And basically what the organization did was develop a backdoor that would get kicked off by passing it a secret encrypted code. And so what we did was, as soon as we heard about it, we actually took that code, implemented in the backdoor in it. Basically, we're able to then kick off the backdoor itself. And as soon as you kick off the backdoor, Rampart immediately detects abnormal behavior occurring within the SSH server, and we're able to detect it and prevent it. And that really was what Rampart was developed for, taking a code base that could have backdoors in it that somebody wants to exploit. And the first time they try to exploit, Rampart would be able to detect it. And so in that case, the security personnel that found it because their application itself was running a little sluggish, and spent a lot of time trying to figure out why. So you had somebody that was very diligent, spending a lot of time, was able to detect it. If that had gotten through, it would have had a massive impact on organizations around the world. But anyone that was running Rampart would have been detected immediately the first time they tried to use that exploit. And that's what's so cool about Rampart.
So I'm going to pull a thread on a couple things that you've said to me over the last couple months. There was an FBI announcement or something that came out a while ago that basically said that you have to assume that the attackers are behind your firewall. Tell me more about that.
So it was earlier this year, the FBI did a number of announcements. The first one was saying that organizations were attacking critical infrastructure. And then they went further on to say, not only they're attacking critical infrastructure, but we have to assume that they're already inside of our firewalls, on our networks, and potentially have been there for the last 5 years.
And they're just slowly, patiently through the supply chain, just embedding themselves, waiting for an opportunity to wake up, I guess. Is that how you think about it?
Yeah, it's through supply chains, it's through moving laterally on the network. But the main thing is to be able to be there. The whole cyber game is to basically be in place and be able to use it at your calling. So for an organization that wants to wreak havoc, you saw that over in Ukraine, the first days of the war, the Russians screwed up some of the power systems and things of that nature. So that was an attack that was lying in wait, waiting to be kicked off. I think that's kind of the game that's played.
Interesting. So you said, again, another thing you said to me over the last couple months is that you guys chose to solve the hardest problem first. Tell me about that line.
Yeah. So what we went after is this whole notion of basically within a code base being able to detect and block applications from abnormal behavior from occurring. So basically we can take an instrument, an application, and know that at any given time we can prevent bad attack from happening and allow the application to stay up and continue to run as expected. It's a difficult problem. And that's the first thing that we went after. And then over time, we've continued to take that concept and apply it to containers. So we started at the application level itself and instrumenting it, moving it to the container level to understand the container itself. Now we're going to move it to the network layer finally. Because everything, as I said before, security is a multi-layered approach. You need many layers in order to be successful.
So you mentioned going from the application to the container to the network. Does the fundamental approach change at all, or is it still the same kind of behavior-based model?
Its behavior-based model is very resilient and it works at all those levels. In fact, it's built the same way. So we have a very holistic approach to how we build our models, build our behavior models. And from a single deployment within the ICD pipeline, we can monitor containers, applications, advanced threat detection, things of that nature, all from within the same pipeline. You choose how you want to deploy. I think that's one of our strengths is basically once you understand the behavior of your system, it gives you great insight into how things should work.
So you guys have actually been deployed into aircraft and different things. Tell me a little bit about how that works and how that might be different from classic IT data center-based software.
So the majority of our work has been more on the IT side. We're currently looking at embedded systems and using it within embedded systems itself. Embedded systems have some interesting aspects of them. And whether you do it as a digital thread or whether you do it as embedded into the system itself, there's some intricacies that involved in it. It also depends on the system itself. So, but we actually did start in the IP world and are moving out into the embedded world. It's actually how we're doing it, Mike.
So, Lee, you've told me in the past that you can basically start with any application anywhere. It doesn't have to be containerized. It doesn't have to be modernized. What are some of the challenges associated with securing an application? It's legacy, monolith, not well written. What's some of the challenges that you face engaging with those kinds of products?
Again, I think everything, and this is where we are very much aligned. Modernization is a multi-stage process.
Yeah.
So the first stage is getting it to a point that it's stabilized and we ensure that it's operating in a way that is acceptable and it's secure. That's, to me, is this outer level of a container as a way for us to just encapsulate it, I like that word, and ensure that system calls are in line with how the application works. And again, whether you have a lot of testing, which gives us a very strong model, or very limited testing, we still have an idea of how that application is supposed to behave. So that's kind of the first stage. Once you understand how the outer level is, you're ultimately going to start really digging into code and doing modernization. And I think there are three things that you want to find. Code that doesn't need to exist anymore, has been deprecated and not used. which I consider to be we should just be remove and reduce the attack surface. There's code that isn't used very often, but you're spending a large amount of money maintaining it. That's another area that's important to consider. The area is just the need to rewrite it.
Is we've, I don't know if our listeners know, because I don't talk about this much online, but about 4 or 5 years ago, we invested in a studio. And so Matt Van Vliet came over. We've done some podcasts with him talking about some of the work that we've done on the technical side. And, for kind of my core listener group, if they're still hanging out with us here in this deeply technical security conversation, there's limits to the level of agility that you can get just by doing process and organizational design, which has been our sweet spot. So that kind of evolved into being able to do some product extraction work, some app modernization work, some engineering modernization, introducing XP practices, test-driven development, continuous integration, CI/CD pipelines, stuff like that, DevOps. So we've been playing in that space for a few years now. And one of the big things that we have noticed in the market is that as folks have moved to the cloud, costs are spiraling out of control. And then they move to the cloud with the hypothesis that they're able to take advantage of the cloud's native services, the security services, the AI services, the ML services. And when they lift and shift these monoliths, that they're not actually able to do that. So their costs go out of control and they're not able to consume these strategic services. So we were talking internally about a lot of that language, and we were putting together some offers that we put together around how to take costs out of the system to fund modernization. And then as you start to, do the app extraction and get your code base healthy, we create an economically justified model for doing that. So I guess my hypothesis in this, maybe we can explore it a little bit, Lee, is that the app has to be secure and it has to maintain security while it's going through these modernization efforts, right? A lot of these apps are already insecure. So tell me a little bit about what that path looks like. You have a legacy monolith that gets moved to the cloud. Costs are going out of control. You can't consume the strategic services from your cloud provider. And so you go down this path of pulling that application apart, strategically refactoring it. Where does Rampart come in to that story for us?
So I think Rampart is kind of your partner along the journey. So Rampart starts out with ensuring that we can secure the outer side of the container. But as you continue along that journey and do app modernization, you want Rampart to continue to learn what is the new behavior of the application and continue to build a behavior model that shows that we can secure it. And so you're basically ensuring that as you continue to do modernization, security is only being improved. It also gives us the ability to ensure that we can actually prove to that customer what you started with, what you ended with is operationally identical, and yet the efficiencies are built into it. You can see a smaller code base exists. You can see those efficiencies associated with the maintainability of the code over its long term. And I think another important point is not only are we getting it to a stable position that modernization can occur, we're securing it during modernization. And then once it's actually in the field, it's continuing to secure it during the deployment of it in its life cycle. And so just as much as we say that the agile methodology is kind of a life skill that you continue to use, how you maintain your code, Rampart's coming along for the ride and continuing to improve the security posture along that journey as well. It's a life skill that's built into your software.
So I have an interesting thread that I want to pull, because this was something we talked to. You and I got together down in, you're down in Melbourne, I'm up in Atlanta. I think we got together in Fort Lauderdale a couple of weeks ago. Mm. And one of the things that I was pressing you on a little bit, just for my own edification, I think for somebody to want to go down this path, you almost have to believe that somebody's already behind your firewall, that somebody has already infiltrated your application. So in the current security world, is that the only belief that has to be overcome? Tell me a little bit about like the executive sociology and the CISO suite or something. around how people are thinking about security and how that fundamental thinking might be somewhat flawed.
Okay. So I think I'll clarify that statement a little bit. So,
Yeah, please.
so I think what we're really getting at is over the last year, the mindset in the C-suite, CISOs, CEOs is changing from the standpoint of I have a firewall and I have a moat and everything's going to be okay. I'm doing the best I can. To understanding that the new emerging threat through AI, it makes it so that we can't keep up. Current tools do not keep up, right? And we see that in current threats that exist today. In addition to that, you have the whole supply chain attack vector that needs to be accounted for. And so you have multiple vectors of attack with an old aging tool set that's based on brittle rules, and organizations are being put on the hook to say to their boards that our systems are secure. Well, before everyone would say, we got this under control. Well, once the FBI came out and said organizations may already be on your network, it's very difficult for somebody to say, we got this under control. It's more prove it to me. And Rampart is a prove it to me methodology. Rampart proves to you that your system operates as expected. By proving that it operates as expected, you can guarantee that your system isn't being taken advantage of. And now, even if there is bad actors on the network, Rampart's going to detect their activity and ensure that no damage is done. And I think that's what's really neat about it. It's a new kind of thought process.
So there's an interesting thread. So that was a clarifying for me. So we're believing that the bad actors are already through the firewall, but I was thinking about it as we talked about the idea of securing the application. But you're saying that AI is actually increasing the sophistication of the threat to the firewall too.
Oh, absolutely.
Is that what I'm hearing you say? Tell me more about that.
Well, just like anything else, you actually even saw it with Log4j. So when Log4j came out, they immediately had a patch and how to protect it. And during that day, I think they issued 3 or 4 other patches because the system was able to determine other ways to encode the attack around the rules that were in the firewall. Anytime you have rules or you have a brittle system that's protecting you, there's ways around it. And I think what you're seeing is AI makes it easy for people to figure out ways around it. And I think that's the point that's changing. Before, for me to figure out ways around it, I had to invest a significant amount of time. If AI is going to make it so that the amount of time that I have to invest is minutes, there's no way I can keep up. And I think that's where I was getting back to when you're going to see exploits as a service. It just changes all the rules from the rules of engagement associated with how attacks are done. And so that's where the ability for rule-based systems to keep up with the cadence of attacks falls apart if I can use generative AI and AI as a way to generate the attack. So it kind of comes down to if I can quickly generate new attacks, it's not costing me very much to generate that new attack, but it's costing you significant amount of time and energy to ensure that your firewalls or your systems are used. And even with that, if they generate an attack that changes your rules, you're left blind. You think your rules are working and they're not. It's just a hard fight to be in.
Interesting. So, a lot of people, I probably get the exact language wrong, but like 0-day threat detection. I mean, like everybody does that kind of stuff. Like, tell me a little bit about, and maybe we've explored it a little bit, but in that context, you guys use a lot of the same words to talk about Rampart AI. How's Rampart AI different in that regard?
Well, talk's cheap. So it's easy to say things. It's much harder to do. So what they're really saying is that if a 0-day attack occurs, they can immediately come up with a way to patch it across your enterprise. They feel that's a way of protecting 0-day attacks, right? Okay. What Rampart is saying is the first time someone tries to employ that attack, Rampart's going to prevent it. or at least alert you that somebody's trying to do something that doesn't make sense on your network. And I think that's the real difference. And so in a case now where you look at SolarWinds, for example, was on networks for 6 to 9 months before it was detected, right?
Mm-hmm.
So you're in an environment now where you want to ensure that you detect attack vectors as soon as possible on your network to prevent further infiltration by that adversary or criminal gang or thug or whatever you want to call it, bad actor. And I think that
So the only way to get true zero threat or 0-day threat detection is to make sure that we assume that they're in, we're assume that they're through your firewall, or assume that you're through your network, we assume that they're in your applications, and the idea is just to make sure that no unknown behaviors can happen.
correct.
Ever. So if that's true, then does it matter? Do you go and remove it after that point, or do you leave it there and just let it be harmless? Or how do you think about that?
So again, I said it before that I think you want to patch it, but patch it on your terms. So you can basically say it's not going to be accessible, which is what Rampart ensures happens. We do that in our cyber range every day. We have vulnerabilities and prove that you can access that vulnerability. But at the same point, what we don't want is organizations to be running around saying, I got to fix this, I got to fix that, I got to fix that. I think they want to maintain cadence associated with the development cycle and fix those problems, right? But on their terms. And I think that's the big thing, on their terms. And their terms could be, we're willing to take the risk to allowing it to stay in there and ensure that it's never going to ultimately be executed. That some people may be willing to take that risk, but it's on their terms.
So one question that we got asked by one of our clients was, is Rampart just another security software that we have to install and maintain and respond to? And the specific context is that this particular client was operating under some fairly stringent government DoD security requirements, security policy. And you had a pretty cool answer to that. Do you recall that conversation?
Yeah.
Tell us about it a little bit.
So I think that really what's happening is in the government world, a lot of the requirements are CMMC requirements, which basically gets into this whole monitoring of the application space themselves, ensuring that code that doesn't need to exist is removed, reducing your attack surface and things of that nature. Those are things that Rampart naturally does that improves your security posture and meeting those requirements. And so what you're able to do now is use Rampart to basically come up with a way for you to monitor and ensure that your system's operating as expected and meeting the CMMC requirements. And I think that's kind of cool. I also think that there's one of the other things that happens is that today, majority of tools that are used, this massive amount of telemetry, you take this massive amount of telemetry and try to figure out something interesting associated with that telemetry. So you have massive amount of telemetry coming in on organizations or AI trying to determine, does this make sense or not based on the telemetry? It's a very, very tough problem to win, right? Because there's just so many unknowns associated with it. What Rampart does, it tells you when something bad's happened in your application. There's no hunting around. It tells you where it happened, when it happened, and gives you the place in your source code where it occurred. So there's no guessing. And it'll tie it even back to the endpoint that actually triggered the attack.
So does Rampart, does it actually deprecate the need for the patching and the remediation? Because you said a moment ago that it allows you to do it kind of on your own time. Does just having the application's behavior secured, even though the patch isn't there, even though the vulnerability isn't there, does it allow it to meet the CMMC requirement?
From a standpoint of that it mitigates that threat. So
Mitigates the threat.
It mitigates the threat. So basically that you have to prove that you're mitigating the threat. So if you're using Rampart as a way to mitigate that threat, you're meeting the mitigation of that threat. That threat can occur. So whether you remove the code or mitigate the threat, it's still the same thing in our opinion. Now, again, I think organizations should continue to have good hygiene and fix bugs that exist in their code, right? But again, on their terms.
Mm-hmm. So an organization that's spending 80% of their time doing security remediation could wrap it in Rampart, and that would ensure that those vulnerabilities couldn't be exploited, and then they could burn down that backlog at a pace that makes sense for them.
Yeah.
Let's talk a little bit about what we see or what you see in market around, like this might be obvious to a lot of people that are in this space, but what are some of the costs associated with security vulnerabilities? What kind of impacts do they typically cause?
So I think vulnerabilities basically allow organizations to gain access to your system. Those are the ones that you really care about. Log4Shell, backdoors, that ultimately then allow you to exploit or exfiltrate information off your system or take control of your system. And those are the things that you really have to worry about preventing happening. As part of the game being played is you want to get a foothold on your system, and then the organization wants to become persistent, move laterally, so that it's very difficult for you to get rid of them. Right. That's kind of the game.
Are they typically trying to hold, or it's probably all the above is my guess. Are they trying to hold your data hostage? Are they trying to take you down? Like what are the things that these actors are trying to do?
So I think that there's manifold. So what you saw is ransomware was extremely effective in having people basically pay money to release their code, to release their data. People then realized all they had to do was back up their systems effectively, and they had a right way around ransomware, right? And now there's governments using advanced techniques to track down criminal gangs and basically put ransomware as a service out of business. What we see as the next frontier is at the application layer. And at the application layer, not only can you hold the data hostage, you can hold the application hostage as well, which is going to be much more difficult for an organization to fix. And so that's the bread and butter of your business. And if they are able to stop you from running your business or impact your business at their will, is going to have a huge cost on you and your organization. So I think that
why is the application security, why is that harder to fix? Because it's been in there for 2 years and your backups are full of it? Is that the idea?
Just how your organization is running. So your data is very easy to back up. If you're basically wiping your computers clean and reapplying all your applications on them, hoping that you're going to get rid of the vulnerability. But if the vulnerability is built into the supply chain itself, it's not going to go away.
Yeah.
So then you have to really understand what's causing the problems. It just becomes much more expensive.
Got it. I got to figure, like, reputational hit, public relations, that kind of a thing. What are you seeing in the industry? Like what's the downside, just even beyond economics or immediate economics of remediation for companies that are getting hit with security violations or security attacks?
Well, I think that there's threefold. One, SEC wants to hold organizations fiduciary duties associated with cyber is something that's been pushed around in the SEC for a while. As soon as they make boards responsible for it, I think things will actually change a lot. I think people want to basically exploit money. They want to ruin reputation. They want to hold you hostage. You're starting to see it with ransomware. Similar things that they do for ransomware will be done at the application level. It's just more effective at the application level because you actually have full control.
My thought is with Rampart AI is that, so we come in and we have a transformation client and we do our structure, governance, and metrics, and we start organizing teams around technology. We look for encapsulation, modernization, engineering, uplift kinds of opportunities. So my thought is that in the early stages of that, before we start pulling applications apart, that we take Rampart AI and we wrap the perimeter of it. So what goes on from there, Lee? Right. So as we start to pull it apart, is it like wrapping Rampart AI around the progressively smaller parts
Yeah.
of the application? Is that how we should think about it?
Yeah. So I think a couple of things on that. So the vision and hypothesis that we've talked about is that how do you gain insight into how the application itself is supposed to work? What is the attack surface associated with that application? So you're thinking in security terms as well as modernization terms. How do we ensure that we
Hmm.
reduce the security footprint, right? You reduce your attack surface. How do we ensure that we understand what codes or what threads are actually used through the application? And so it's kind of twofold. One is this containers becoming smaller and smaller, focused on doing a single job, right? As well as the
Hmm.
instrumenting of that code itself to determine is the code performing as expected, the code itself. So I think again, it comes down to where we see the biggest bang for our buck associated with greatest risk areas as that modernization occurs. And I think that's one of the things that your team is so good at is figuring out where to focus your energy in order to get the biggest bang for your buck initially as you continue to grow that modernization across the enterprise.
We were bouncing around some ideas and I'm just riffing with you a little bit. If so one of the things Matt and I were talking about was the idea of it almost provides the basis for some like characterization tests. Could you actually use the information coming out of Rampart AI to generate tests? Like almost use like the information to create your automated test framework. Is there something there?
We've played with that a little bit. It turns out to be a pretty hard problem to do it reverse engineering of it, just because of how modern software interacts. It's not a single thread through the system. There's many layers
Yeah.
associated with it. So it's not the most cost-effective way to do it. I think what we can tell is what percent of the code is being executed and things of that nature to give you some level of understanding of
Hmm.
how broad a test coverage you have of what's operationally used. And so that's another thing that's very different is you can look at it from a static standpoint, right? But understanding what part of your code base is actually running your business, I think is very important to understanding where do you spend your time doing the modernization.
Okay. Yeah, we were actually riffing on the idea of what if you could use the output of Rampart AI and then use an AI to write automated tests for the different behaviors that we saw. So a hard problem, huh?
It's a hard
Matt
problem.
was pretty excited about it. Matt was pretty excited about it. That
But,
was awesome.
I guess that's the things that would have to happen in order to do that is that you'd have to have a large language model that
Hmm.
does an analysis of your code, takes the analysis of your code in concert with Rampart AI's results, and then basically can prove that the output of the testing at the operational level meets the needs of the threads through the system, that they align. I
Hmm.
think you could get there, but I don't think it's a tomorrow problem.
Yeah, I agree. I mean, I think part of the challenges that we see with a lot of our clients is that their test coverage is wholly insufficient. That was actually something that was interesting because just even aside from the modernization and the extraction work and containerization work, something you said, and it proved not to be 100% true, right? But it starts its initial learning from tests. And my initial reaction to that is that so many of the clients that we work with just have just such poor testing frameworks
Right.
around their code. So so it either creates a business case for writing tests, or maybe in some future state, right, it could actually generate tests.
Yes.
Is there a, yeah, go ahead.
So I think that's really an important aspect. As we build modern systems, we want to be able to rapidly deploy these systems. The only way you're going to have rapid deployment and ensure that the system behaves as expected is to have automated operational tests. And so
Yeah.
for organizations that rapidly want to deploy, by definition, they need operational level testing. And I think that's one of the things that we talked about as part of that modernization stage, is understanding the test inputs that ensure that the application behaves as expected. Because ultimately what you want is to have the same interaction with your system, the same results, just occurring significantly more efficiently. Because really, if you remember back in the day, everybody would add code to applications, but no one would ever remove it because they were afraid they were going to break something.
Yeah, sure.
That's just a failed strategy. We should understand how our systems work, right? We should know what we can take in and we got to improve it to ourselves.
Well, so what's fascinating to me is that I'm just going to pull a thread here. So we work with a lot of companies that are like the products of mergers and acquisitions, right? So there's just been software that's rolled up and rolled up and rolled up. And I sit in some of these rooms with some of these engineers, and they're so smart, right? And they've solved such hard problems. But there's something about like when you start to roll them up and you start to package them together and you start to build integrations between them, it's just like, I think you take like the ownership of it off of the original engineers, and it just starts to devolve over time. I got a degree in computer science back in '93, and never used it much professionally, but it was kind of a nice level of understanding to have in my back pocket as I've done different things through my career. And one of the things I ask Chris Beal a lot is, why are these practices so misunderstood and so inconsistently deployed? I would be curious your take on the industry regarding disciplined software engineering. What are your observations?
So I think a lot's changed over the time, that 30 years time frame that you're talking about.
Yeah.
So when we first started developing software, you developed software as an art. You were writing code, it was unique. You did some level of test cases, it got rolled up into integration, and they just kept rolling and rolling until they got a product. And they were very happy they got a product that worked. Then we started moving in and we said, software is too expensive, so let's come up with better ways to improve the efficiency. We went on a very much efficiency of building software binge. How do we build it more efficiently? How do we make it more modular? How do we make it be able to reusability of code? And all these things occurred. We put the risk associated that someone was developing good code on somebody else. And we just linked those modules together. And as long as we still got an end result, we said it was good. Then all of a sudden, then we made this whole notion that not only does it have to be efficient, it has to be secure, right? And so each of those levels, we kind of changed the methodology associated with it. And I think what you're seeing now is because of that, we have many different levels of software that's built to different standards that they're associated with, that are all merged together as an application that works or perceives to work or is good enough that ultimately people now want to port to the cloud or port to a more modern architecture, and realizing, wait a minute, I didn't realize it was held together this way. And I think that's why you're starting to see such a change as to why are things so complicated, or why did we make it so hard? I think we've learned along the way. You know, I mean, even if you look at the sophistication of debuggers, you know, I mean, they went from you really had to know what you're doing to it's pretty much telling you and color coding what's wrong with your system. And now you can take it and ask a large language model, if I get this type of error, how do I fix it? You know, I mean, just soon, such an evolution. And soon you'll basically be able to get to the point where you say, large language model, to code up this unit for me using this particular pattern or this particular standard, and it'll do it and test it. And it does that really well at the unit level test, but it's at the operational level test is where you earn your money. Operationally, that's how your systems ultimately get deployed, and that's how they actually provide capability that earns organizations money.
So how do you solve the problem where, I think I read a stat that said something like the number of software engineers is like doubling every 7 years, right? So we have kids coming out of college, and then, it's 30, 35 years later, and we have older guys retiring. Like, where do younger engineers learn how to do this well? Is it like through apprenticeship? You have to work under somebody who knows? Because I don't think these advanced concepts are being talked about in the universities.
This is a huge problem. This is my opinion, so be careful here.
Yeah,
I think we're at
yeah.
a
We're going off the rails. We're totally going off the rails here, Lee.
very transformational state now as far as how software is developed. I think what you're going to see is the concept of having young engineers develop code going to become much more automated from a standpoint of using large language models to develop code. What you're really going to need is for people to think and understand how organizations work, the requirements, the agile design associated with systems is going to be the skill that you need to have, because the grunt work, not the best word, is going to be able to be done by large language models. So think about it. Imagine if you could take your storyboards and you break those down into threads or operational threads of how your system's going to work, and you provide those requirements now to a large language model, and it goes off and builds that code, tests it out, and provides you results. You as the system engineer are going to take that and start taking these building blocks that you've built and putting them together to create operational capability. And I think what we're going to need are people that can think. Critical thinking skills are going to become far more important than coding skills.
Interesting. You told me something that some of the security exploits are actually coming through like Jira or other ALMs, where they're like bad actors are injecting bad requirements that people are coding blindly. Do you remember that comment that you said to me?
Yeah. So what I said was that.
Am I getting it wrong? I'm sorry.
That's a vector that exists today, that if someone can go into Jira and put new requirements that says open port 23 based on when these events occur, and your young engineer takes it and says, it's set to open port 23 and do these things, they're going to write code that does that. And so my point is that people need to think and understand what they're doing and not just take things blindly. And I think that's really, from a security perspective, it's, you have to question and understand what your system does. And people can't do things blindly. People can't build systems without understanding how they operate. You can't test systems without understanding how they operate. The call comes down to the ability we need to understand how our systems operate if we're going to have secure systems. But security doesn't come.
Well, so that gets back to my other question. With so many young engineers coming out of, university, and sometimes the really deep experienced people retiring, like how does that understanding of how these really complex systems work, how does that propagate in the industry? I'm just curious about this. I think it's a fascinating challenge.
So I think what you're going to see again, I think you're going to see more people. We're probably going to have to change a lot of our programs in college to focus more on the higher level requirements, developing of requirements as opposed to focusing on languages. Now, with that said, I brought up the point that you need critical thinking skills. In order to gain critical thinking skills, you need to understand how your systems work. So you still need to go through that same level of understanding how code works. But do I have to give you 30 programs that you need to generate? Can I get that with 5? And have you understand how the integration's done, bringing you more into the system engineering world as opposed to the programming world. So I think we're going to start getting more people into the system engineering side of the problem, more security side of the problem, just escalating kind of higher level of understanding of the system. Because what we did is we just brought people in and said, you're going to code in C++, you're going to code in Java, and we're going to basically, you have some rudimentary understanding of the syntax of the language. We're going to tell you how to develop code in your organization. And I think what you're going to start to see is we're going to start to tell you how our organization works, how system engineering is done as an organization, how test is done in an organization. Imagine if we could spend more time building operational tests and less time building operational code, because that can be done through large language models or other techniques.
So I have a couple threads I want to pull there for a minute. Are the large language models trained on bad code? Like, how do you get them trained on well-engineered code? What's the state of the industry in that right now, Lee?
That's a really good question. So I think that's a problem that exists, right? Because again, you can't just blindly trust a large language model that it's going to do what we said, that it's not going to do something stupid. It's not going to put an exploit in the code, right?
Mm-hmm.
So I think
because there's bad actors that are probably there's probably bad actors that are training the large language models to inject stuff into your code. No,
right. So there's some level of organizations, or at least what I think high quality organizations are going to be able to control the patterns that they say are acceptable to use, things that are approved to meet standards, and ensuring that the code they develop meets the standards and that's tested properly. So I think those are the things that are kind of come into it. And again, I still stand by the point that you need to have this, what I consider to be cognitive understanding of how systems work, as opposed to and applying those critical thinking skills all the time to ensure that just because it says something doesn't mean it's true. Prove it to me that it's doing what I expected. Prove it that it's being tested. Like, I think I like to say, if we're not adding value, why do we have to be part of the process? And our value that we're adding as engineering is ensuring that an engineering process is being followed, right? And that means critical thinking skills along the way, that at every stage we're ensuring that it's doing what we expect. So I think.
So yeah, go ahead.
I don't think we want to say, create a new super dupe application and go do it for me, large language model, and assume that it's done. I still think you want to have agile process that's in place, that has checks and balances along the way, that's proving to you as a diligent engineer the system's operating as expected.
So I had a professor tell me, this is probably back in '89 or something like that, when I had gone to college. You and I both have a shared connection to the University of Florida, which of course I think is cool. So anybody who watches any of my stuff knows I'm a big UF guy, and I do a little bit of classroom work down there on occasion. But back in '89, '90, when I was thinking about going into computer science, I had my advisor tell me, he's like, do we need better computer scientists, or do we need engineers that know how to write software? And I guess I say that do you think software engineering is a mature discipline at this point? Has it become an engineering discipline? Is it moving closer to it, or is it moving further away?
So I definitely think software engineering is becoming a much more proven discipline. The problem that exists in software is there's many ways to implement good code. Whereas some of the other engineering principles, stand up to what I consider to be rock solid Moore's law, certain laws that exist associated with systems or electrical engineering, right? Principles. With software, there's much more flexibility. So I think that what you're seeing is that discipline is getting there, and we started to do it with patterns. And a lot of things that happened, and I think over time will change, is that we couldn't get people to take requirements, write tests against those requirements, implement those requirements, develop software, test the software. What we did was we continued to break it up. And so somebody created requirements, and then somebody else created software requirements, and there was always a disconnect. I think that disconnect is going to go away. You're going to see a much more fluid process happening.
Well, that's really what we're trying to accomplish in the Agile world, if you think about it, right? Teams of people responsible for modules with we'll kind of colloquially call it like an on-site customer, somebody to ask about the business requirements, test-driven development, continuous integration, continuous deployment. Is that the space you're talking about? Is that what needs to happen more broadly
Oh, for
across the
sure.
organization?
But again, it's even, in my mind, it's writing standard requirements, standard test cases that are reusable, the ability to ensure that we use design patterns. We remove a lot of the creativity, that we put security as part of the process. That
Oh, that's a provocative statement. Removing the creativity, huh?
Yeah.
Right. Tell me more. We're gonna try to make some people in our audience mad here today, Lee. Tell me about the level of standardization that you think is necessary.
I think standardization is that I think that what you're seeing is creativity in software really doesn't need to exist anymore. We had a lot of creativity because we had certain requirements associated with limited amount of computer processing. We had to be smart about how we compressed and did things. There really isn't a need for that today. The amount of CPU power that exists on a phone is far superior than the whole computer room at UF when you were in school. You know what I mean? So a lot of things have changed, and we need to take advantage of those, right? And so I think that what you're going to start to see is this notion of focusing on developing a code that operationally works as expected. It's going to be the big piece. And that when I change a requirement as cascades through the system, as opposed to I change code. So we change code, but really we should change requirements that drive code changes. And we have that a little bit backwards. And I think that's one of the things that's going to change. So in the agile world, what you're going to start to see is those storyboards, your meeting customers' needs are going to become quantified as requirements that flow through the system that ultimately allow it to happen naturally. And I think that's why the agile process is only going to become more effective in developing high quality code over time.
So the focus shifting away from writing code to defining the requirements around code, creating the tests around code, and then let the large language models fill in the code.
Yeah.
So when the requirements change, it can just cascade down.
Yeah. See the future.
Interesting. Okay, so another interesting thing. So as I've done my classroom stuff down at UF, like I end up talking to an industrial and systems engineering college a lot. Entrepreneurship, leadership, innovation classes, things like that. Talk a little bit to the computer science folks. I don't have as much to add there, but I have this vision that like if I was going to train somebody in college to be a transformation specialist, they almost need to understand at least a high level understanding of software architecture. They have to have an understanding of organizational design, organizational psychology, change management, project management. There's an element of industrial and systems engineering, organizational psychology, if I didn't say that. Like, so to me, like I think one of the things that's missing in our industry is a coherent model of how scaled software organizations should operate. I would be curious if you have an analog on the computer science side. What do you think people out of college need to be learning that's outside of their core discipline to be able to think the way that you're talking about?
Well, I definitely think that whole side that you just described, how people should interact with the computer, right? How those are things. How is the system going to operate? How are people going to use it over the life cycle? How is it going to be maintained over the life of the product? Are key things that need to take into account. Majority of the cost of your system isn't development; it's maintaining the life cycle of it, right? You get that, right?
Yeah.
So I think what you're saying is that whole psychology of it, the UI UX of it, right? The improving efficiencies of it, making it easy for people to use, making it easy for it to be modified. Right. I think those are the things that people are going to have to be trained in, associated with. And so instead of worrying about syntax all the time, worry about how do I make products that ultimately are easy for organizations to adopt, use, be intuitive, and things of that nature. I also think that you're going to start to see a lot of systems become more interactive. So you're telling the system what you want it to do. I want to create these, bills or I want to create this type of model, or I want to compare these types of things, have the system then go off and do it. So the UIs are going to become more interactive from a standpoint of being able to, instead of me typing everything, I'm probably going to be able to interact with tools of the future, which, we may get to being a fully mobile organization. Everything, you may be able to do everything on your phone. You're able to interact with it to tell it, create this report or create this set of requirements or do whatever else, and have it create the requirements, read it back to you. Do you agree? Tell you the strength and weaknesses of those requirements. We could have a different way of interacting with our systems.
Pretty cool. Yeah. So what starts to emerge in my head is this I'm very much like a systems thinking guy, right? And so, you think about the relationship between the org design, governance models, what we measure and control, the way we think about requirements, the way we think about software engineering, the way we think about testing, the way we think about architecture. And then I think the security stuff is fascinating because it's like if you get that stuff right, then you wrap it in the security and you have this impenetrable moat, I think you've said, around it that makes it secure while it's changing all the time.
Yeah.
It's pretty interesting. It's a really tough story to tell. I've been thinking about it a lot lately because, our home base for so many years has been in this agile transformation space. Over the last 4 or 5 years, the engineering modernization space. Now it's like everything is being driven by costs. So we're trying to figure out how to make everything more efficient so we can do the modernization, so that we can create decapsulation, so that we can wrap it in security, so we can expose it to AI, right? Or AI enable it. Is there anything that I missed that you think we should be talking about? Anything you want to ask me?
So I think one of the things that I think is so critical of why this partnership really is so important to at least Rampart AI, working with companies like Agile, is that transformation that's taking place today needs to ensure that security is part of that transformation. And security is really driving transformation itself. So organizations are forced to become more secure. And it's that methodology that you've developed from an Agile standpoint of understanding the process and making it a lifelong skill for the organization, so that it's not just, this is what you have to do today. It's what you have to do every day. This is how you continue to maintain your system. This is how your system continues to operate. This is how you view your system. And we start to look at it from a security and a testability standpoint. We've actually given organizations the tools that they need for long-term success. And I think that, a lot of organizations complain that things are expensive. But again, majority of the cost is in maintaining the life cycle. So there's endless budget to fix a security flaw. Practically endless budget exists. Why don't we develop systems that are secure so that we don't have to freak out and run around trying to understand what has happened to my organization, what's happened to our applications? Why not build that from the beginning? And that cost that's paid up front will pay dividends over the life of that program. And I think organizations are starting to realize that.
Well, what was interesting to me, right? I think I'm reiterating or maybe building upon what you just said. The reason why I thought our relationship was neat was because, you start to think about the business drivers, and you said, just now that, people will spend endless money on security remediation, but if we could solve the security problem more simply, create the safety around it, fund the app modernization, fund the engineering uplift, get the software in order, organize the teaming strategies and the value streams and the governance models and tie it up to OKRs. So you start with the immediate problem, work back to the transformation, and then the transformation is resulting in code that doesn't break anymore. Kind of a thing. That's kind of what I was hearing you say a little bit, but I think there's something there.
Yeah, exactly.
So I think, what we're seeing a little bit, it's like the entry point. So 10, 12 years ago, people were like, yeah, I want to be more agile for various reasons. Now it's like we're finding ourselves in a world where if we're not taking costs out, we're not making things more secure, we're not improving efficiency, flow, all those different things in a very measurable way. People have less appetite for change's sake, or a hypothesis that Agile is going to solve it. So again, what I think super interesting is that security is a big deal, right? Cloud costs are a big deal. Getting ready for AI is a big deal. And you have to work backwards. So you say, okay, that's a big deal. What conditions do I need to create in my code base? What conditions do I need to create in my organization so that I can exploit these things and these capabilities in the future in a more scalable way? More scalable.
I think that's a really great point, because part of that transformation, in my mind, is this understanding of what are new technologies that can be employed within your organization to allow it to be more efficient. So when you're doing that transformation, it's not only just moving the code itself, it's looking at, from an organizational point of view, what is the best way to do it? And how do you get there over time? And what's your appetite for cost? I mean, to tell everyone that they should switch to use AI today, to me, is not the right answer. But there is a gradual transition, right? Because that agile transformation that allows it to happen, so that you understand in the future that these things, it doesn't make sense for us to do the transformation of this part of the organization today, because the grander vision is for it to be transformed this way, and understanding that piecemeal approach that's going to come together in a cost-effective manner. I think that's really important. And I think, again, what people miss is that when they do this agile transformation, it's going to allow the system to continually evolve, right? As opposed to we built monolithic systems before and we never wanted to touch them again. And the way it worked today was the way it was always going to work. Then we realized, well, it had so many vulnerabilities associated with it, you can't even afford to allow it to work that way anymore. And I think that
all I was going to say is Bob Martin one time said something from stage. He was doing a keynote at a conference I was at. This is probably 10, 15 years ago. He said, if we knew this code was going to be in production 40 years from now, we probably would have spent a little bit more time on its architecture. I just think that's kind of an interesting comment to make.
Yeah, that's absolutely correct. And I think that that's why agile transformation is so important, because it's allowing you to have the hooks in the right places and understand that it's an evolving methodology. It's not set in stone. And if we develop systems with security in mind, develop and understand that they're going to change over time, and develop that security is really focused on the execution. So a lot of people think they can solve security at the code level. You're never going to solve the security problem at the code level. It's just too hard, too expensive to do. Now, that's not to say that you shouldn't try, because I think that's kind of like just good hygiene associated with software development. Large language models will ultimately do a good job at that. But you really earn your keep is at the execution stage, and ensuring your system executes as expected. No one's taking advantage of you during execution.
Yeah, super interesting. Well, this is a great conversation, Lee. I appreciate you taking some time with us. Thanks for joining us, and look forward to doing this again sometime.